it can easily wash away the surface of the soil. Even water, the flowing water or running water can easily wash away the topsoil, leading to soil erosion. Another disadvantage there, another problem associated with this is depletion of some of forest products. That's why many laws have been enacted against the indiscriminate felling of trees. Because if these are allowed, a time will come when there will be a total depletion or a total loss of forest products. Some species of trees, some species of forest product will no longer be there. It would have gone into extinction because of indiscriminate exploitation of the products. Extinction of some wild animals. This is already a problem, a serious problem in our society, as we can no longer lay hands on some ancient animals or wildlife because they have been exploited, overexploited, until they have gone into extinction. That's to say, they are no more in existence. Some of us only read about them in books and documentaries, but physically or in terms of real life, they are no longer in existence. So this is a serious problem associated with exploitation of vegetation resources. Apart from this, flooding is also a problem, another problem associated with this practice. And flooding comes with its own menace. It can lead to loss of life and property. Another effect or another problem is the effect of wind. Now, if the trees which serve as windbreakers are cut down or overexploited, when the wind begins to blow, you discover that there are no resistances, and as such, it can lead to loss of life and property, just like flooding. So having known this, having considered these problems, what possible solutions can we prefer or suggest to curb, or better still, eradicate these problems? Now, if we know that falling of trees indiscriminately will lead to soil erosion, will lead to extinction of some products in the forest, then certain laws should be enacted. And not only enacted, they should be properly enforced, just like what is going on in Cross River State, where a team is being trained to enforce these laws such that defaulters are seriously dealt with, to serve as deterrents to others who may want to indiscriminately exploit these products. And another solution should be encouragement of afforestation. You cut down one tree, you plant two. These will go a long way to curbing these problems. Now, let's look at basic concepts in map reading. Basic concepts in map reading. To start with, what is a map? Map here is a representation of features of the earth on paper. Now, before I go further, let me say this, that this aspect of geography is usually regarded as the practical aspect of geography, because students are engaged in some practical works such that they have to look at topographical maps, try to interpret them, and try to give meanings to what each of the signs and symbols represented on the map mean. So, and it usually require enough commitment and some thinking work so that you'll be able to put all these things together to come up with a meaningful interpretation of a given map. Now we said that map or a map is a representation of features of the earth on paper. You see that a whole country, the features of the whole country can be represented on a two-dimensional sheet, a paper. So when that is done, we say that we can refer to that as a map. Maps could be topographical, it could be atlas, it could be plan, or sketch maps. But for purposes of this study, topographical maps are going to be used. Now, every map has a scale. And without a scale of a map becomes meaningless because one may not be able to know what is the relationship between the distance in the map or in the paper and the distance, the actual distance on the ground. You cannot tell me that 2 cm on the paper is 2 cm on the ground. It doesn't make sense. But when there is a scale, that relationship will be there. A scale tries to relate the actual ground distance or measurements with the measurements or distance on the paper. So now, map scale refers to the relationship between the measurement or the distance on the map and the actual ground distance. And that's to say that if the scale of a map is 2 cm to 1 kilometer, it therefore means that every 2 cm you encounter on the map or on the paper represents 1 kilometer on the actual ground. So that's what the scale of the map does. Now, there are types of scales. One, we have a statement scale. For example, if we have a statement like 1 cm represents 2 kilometers or 1 cm to 2 kilometers. That is a statement scale. Now, let's consider how to use the statement scale. The first thing you do is to note the two places involved. Then you measure the distance between the two places using ruler. If the distance is a straight one, you use ruler. But if it is curved, you use a thread. Use a thread, and then you curve the thread according to, just trace it according to the nature of how curvy the distance between the two places you're talking about is. Just trace it like that accordingly, and then you get the distance with the thread. Then from there, you take it back to a ruler to know the actual length, and then straighten up on the ruler. I'm talking about the thread now. Place the thread on the ruler and then get the true measurement. Now, if that has been done, you relate the measured distance with the scale. You relate the measured distance, the distance between the two places involved, with a given scale. Now, there's an example here to further help our understanding. Now, for example, if the scale of a map is 2 centimeters to 1 kilometer, what will be the ground distance if the distance between towns A and town B on the map is 10 centimeters? Now, in a case like this, already it is stated that the scale of the map is 2 centimeters equals to 1 kilometer. And we want to know what will be the ground distance if we have a distance between two towns, A and B, to be 10 cm. The given scale of the map is 2 centimeter is to 1 kilometer. That's to say that every 2 centimeter you encounter on the map, that's the paper, will give you 1 kilometer on ground. And now, a distance between two towns, town A and town B, was measured. And the distance was equal to 10 centimeters. Now, the question is, if the distance between town A and B on the map is 10 centimeters, what will be the actual ground distance between these two towns? Now, if 2 cm is to 1 kilometer, 2 cm equals to 1 kilometer. The 10 cm will equals to what? That's what the question means. So if we do the simple arithmetic operation here by cross multiplying, you will have that if you cross multiply, you have that 2x or to 10 x 5 kilometer. So that's to say that on the ground, the distance between town A and town B is 5 kilometers.